Okay, now it's your turn. Two unusual questions that I'm going to explain, but I'm going to leave you complete. And I'll upload the marking schemes then and talk you through anything that you need to be talked through. So the first one is 1992b. This is the question. Two equal smooth spheres, so their masses are the same. They're of radius r, and they're moving horizontally in opposite directions with speed u. Now they're offset by each other. Their centres lie on two parallel lines a distance r apart. The coefficient of restitution is a third. Now this is a more complicated question than it appears to be a more complicated question than it actually is. Like all the questions, you need to see what happens when they collide. So when they collide, they look like that. What we know is the distance between the two centres is equal to 2r, and we also know that the line between those parallel, the length between those two parallel dotted lines equals r. So number one, I would rotate the spheres, and also you can verify that the angle there is 30 degrees. But like I said, I would rotate the spheres. Now, because we're rotating the spheres through an angle of 30 degrees anti-clockwise, that will mean that the sphere on the left with a U that's horizontal in the top left-hand diagram, you'll need to rotate that U 30 degrees counterclockwise, and the U going towards the left from the sphere on the right-hand side will also need to be rotated. So the U's will end up going in that direction. Now, they were going horizontally. They've both been rotated to 30 degrees, so now the angle between both of them and the horizontal is 30 degrees. So you should be able to get your two vectors for each of those. The rest then should be fairly straightforward. You're looking for, to prove the angle is 30, I've kind of explained that. Find the velocity of each sphere after impact, that's just a standard question. And what fraction of kinetic energy is lost as a result of the collision. Remember your fraction of kinetic energy loss formula for that. Now I'll post the marking scheme in a moment on that. You can pause this video. I'm going to have a look at question 2 of the unusual question variety. Okay, this is from 1990. The first paragraph there state the laws governing the oblique collision of two smooth spheres. You're just stating the principle of conservation of momentum and Newton's elastic law. Then we're told a smooth elastic sphere of mass 6 kgs rests on a smooth horizontal table. That's the bottom sphere. A second smooth elastic sphere of mass 4 kg falls vertically on it, so it travels down. At the moment of impact, the line of centres makes an angle of 45 degrees with the vertical, and the velocity of the falling sphere is u. The 6 kg sphere moves horizontally after the collision. I'm going to come back to question 1, and what I would suggest here is redrawing that diagram after rotating it through what will be 45 degrees, so that the line joining the centres is horizontal. Now you could also do it so that the line joining the centres is vertical, your choice, and then you can just plough through the question as you normally would. There's a problem with this question though, and that is the principle of conservation of momentum says that the momentum before equals the momentum after, so long as no external force acts on the system. However, that top sphere is falling. There's an external force acting on it, which is its weight, so the principle of conservation of momentum should not apply. However, question 1 says, explain why the principle of conservation of momentum may apply horizontally. As far as I understand here, what we're looking at can be explained in two ways. Number one, we're looking at what happens instantaneously at the moment of collision. So we're not interested in the fact that it accelerates beforehand or its weight causes it to accelerate. We're just looking at what happens at the moment of impact. So we can ignore that external force. Or option 2, there's a force downwards when it collides, which is its weight downwards, but also there's an external force acting on the bottom sphere, which is the reaction due to it and the table, and that's vertically up. And those forces, you could argue, are equal and opposite. I'm less convinced about the second one, and I'd imagine that the first one is what they're expecting you to come up with. But in the real world, neither are correct, right? If it comes up though as an exam question, what I would do is just treat it as though you're looking at the system from above, and that the particles aren't falling, they're traveling horizontally, and then rotate that through 45 degrees and complete your question as before. So I'll leave you work away with that. Pause the video here and answer the question, and I'll post the marking scheme in a moment.